ground fault circuit interrupter, or GFCI, breaker is required for a 240 volts pool heater installation. The National Electrical Code, or NEC, mandates this protection. The requirement exists irrespective of the heater's physical distance from the pool itself. The primary reason for requiring GFCI protection is safety. GFCIs are designed to detect ground faults which occur when electrical current strays from its intended path and flows through an unintended conductor, like a person. Such ground faults can result in severe electrical shock or even electrocution. In the context of a pool and its associated equipment, the presence of water significantly increases the risk of electrical shock. Even if the pool heater is located a distance away from the pool, the potential for ground faults and the presence of conductive pathways through the ground make GFCI protection essential. A GFCI breaker works by monitoring the current balance between the hot and neutral conductors in a circuit. In a properly functioning circuit, the current flowing through the hot conductor should be equal to the current returning through the neutral conductor. If there is a ground fault, some of the current will divert through an unintended path, creating an imbalance between the hot and neutral conductors. When the GFCI breaker detects this imbalance, typically a very small difference of around 5 milliamps, it quickly trips the circuit, cutting off the flow of electricity and preventing electrical shock. The NEC specifies GFCI protection requirements for various electrical equipment and locations around pools. It mandates that all electrical outlets and equipment within a certain distance of the pool's edge, typically 6 feet, must be GFCI protected. This includes pool heaters, pumps, filters, and other electrical devices. The NEC also addresses specific requirements for pool heaters. These requirements emphasize the need for GFCI protection to minimize the risk of electrical shock to pool users and anyone in the vicinity of the pool equipment. Installing a GFCI breaker for a 240 volts pool heater involves several steps. Firstly, ensure that the breaker is properly rated for the circuit. The breaker's amperage rating should match the circuit's amperage capacity. Secondly, connect the breaker to the circuit's hot and neutral conductors. The hot conductor is typically black or red, while the neutral conductor is white. Thirdly, connect the GFCI breaker's ground wire to the grounding system. The ground wire is typically green or bare copper. Fourthly, test the GFCI breaker to ensure that it is functioning properly. Most GFCI breakers have a test button that simulates a ground fault. When the test button is pressed, the breaker should trip, indicating that it is working correctly. It is also advisable to use a GFCI tester, which plugs into an outlet and verifies the GFCI's tripping threshold and response time. There are different types of GFCI protection available. GFCI breakers provide protection for the entire circuit, while GFCI outlets provide protection only at the outlet location. For a pool heater, a GFCI breaker is typically the preferred option, as it protects the entire circuit that supplies power to the heater. When selecting a GFCI breaker, it is important to choose one that is specifically designed for pool heater applications. These breakers are typically rated for higher amperage and are designed to withstand the harsh environmental conditions often found around pools. It is also important to follow the manufacturer's instructions for installation and testing. In addition to GFCI protection, other safety measures should be taken to minimize the risk of electrical shock around pools. These measures include ensuring that all electrical equipment is properly grounded, keeping electrical cords and devices away from the pool water, and avoiding the use of electrical appliances while in the pool. Regular inspections of the pool's electrical system are also essential to identify and address any potential hazards. These inspections should be performed by a qualified electrician who is familiar with the NEC requirements for pools. During an inspection, the electrician should check for any signs of damage or deterioration to the wiring, equipment, and grounding system. They should also test the GFCI breakers and outlets to ensure that they are functioning properly. If any problems are found, they should be repaired or replaced immediately. It is also important to educate pool users about the dangers of electricity and water. They should be instructed to never use electrical appliances while in the pool, to keep electrical cords and devices away from the pool water, and to report any electrical hazards to the pool owner or operator. By taking these precautions, the risk of electrical shock around pools can be significantly reduced. In summary, installing a GFCI breaker for a 240 volts pool heater is a critical safety measure that is required by the NEC. GFCI breakers protect against ground faults, which can cause severe electrical shock or electrocution. They work by monitoring the current balance between the hot and neutral conductors in a circuit and tripping the circuit when an imbalance is detected. When installing a GFCI breaker, it is important to choose one that is properly rated for the circuit and specifically designed for pool heater applications. It is also important to follow the manufacturer's instructions for installation and testing. In addition to GFCI protection, other safety measures should be taken to minimize the risk of electrical shock around pools. These measures include ensuring that all electrical equipment is properly grounded, keeping electrical cords and devices away from the pool water, and avoiding the use of electrical appliances while in the pool. Regular inspections of the pool's electrical system are also essential to identify and address any potential hazards.